Welcome to the channel. I'm Barney and this is about ballistics. Today's video will be about reloading, and reloading includes some dangers, so you got to know what you are doing. The danger we're talking about today is overpressure. So where does this pressure come from and how can it be overpressure? Now what we are doing is we are burning a propellant in a confined space. That confined space is defined by the volume of the case where the powder sits in and the disability of the case to expand during ignition by the limitations of the chamber. When we are igniting that powder, chemically stored energy is released and will produce a quite significant amount of gas. Now this gas will generate pressure, and this pressure has nowhere to go except pushing a bullet down the barrel. If things are normal, the gun is designed to handle these pressures. Under any circumstance, we want to avoid the situation where we think that space would be larger than it actually is. If you put the same gas into a smaller space, the pressure will increase significantly. That's what we call overpressure. We have tools like GRT to help us with the simulation to check if that's happening. In order to get a correct simulation result, we have to tell GRT what the volume of our case actually is. If you pick a caliber from the database, there will be a number here, but for sure it won't be matching the actual volume you have. In fact, case volumes will vary greatly by manufacturer. So take a fired case, put it on a scale, zero the scale, and then drip water into it. If you add a little soap to the water, it will free you from surface tension, getting you better chances to fill the case up to the brim. Repeat this 10 or 20 times. Make notes of the weight of the water inside the cases and then make an average calculation about that. That will be as close as you can get to a case volume sufficient for a good simulation in GRT. The next thing we need to enter is the projectile mass, which you can determine by weighting 10 or 20 projectiles and calculate an average again. We also need to enter the correct projectile length, and you can determine that by using a caliper, again for 10 to 20 rounds or bullets, and then make an average calculation. If everything else is set to standards, we're pretty much good to go. But there's another thing which gets in practice screwed up quite a bit, and that is the initial pressure. Now, initial pressure is a value which helps the simulation to have a kickstart from a initial pressure, as the name says, into the curve it actually is plotting out. So we have different values for different calibers or types of calibers and ammunition you can choose from. And if you don't know the correct initial pressure, you can actually press on the star here, which will go to an assistant or wizard and will lead you through the process. If you press on the star, the assistant will open and you can select your caliber type, whether it's a pistol or a revolver, a rifle or a shotgun. You're then selecting the type of bullet you're using accordingly. Finally, determine the primer type. In this case, rifle, jacketed bullets, available is standard or magnum primer. If done so, GRT will provide you with the correct initial pressure value. So after we completed the last step, we're good to go to have some realistic simulation results. The next thing we want to do is we want to find a powder mass entered here, which will lead to a pressure curve with a maximum pressure barely touching the Pmax minus 15% line. You can see this purple part here, that will be overpressure. That line here is the Pmax, the maximum pressure. This line here and the red area between is it's Pmax minus 15% until Pmax, and that gray area here is Pmax minus 25% until Pmax minus 15. So if we have a shape like this, we're good to go for the next step. We're going to select a load development ladder. I usually take 5 steps, and there should be a stepping, which is a recommendation here from our friend Charlie for different types of ammunition. This will generate 5 pressure curves from, the one we're started with down to one which is 4 times the stepping we put inside. And those will be differentiated by the stepping value in powder mass we entered. Now, the individual powder masses corresponding to that individual curves can be found here. Load 5 rounds with each of these powder masses we found, and then go to the range and shoot them. You should label them correctly in order to be able to identify them correctly, and then start with the lightest load, which will in the simulation be this curve, and work your way up. So when you are shooting, there are things to observe. So don't only focus on your size of groups and your breathing and trying to, put the bullets into the right spot, but, also have some recognition of what's going on else. Recoil. I mean, this is not scientific, but if you shot this rifle before with factory ammunition, just watch out for recoil. If it feels, significantly heavier than it felt before, you got to check other things. We're coming to that. Muzzle flash. Do we have an extensive muzzle flash? Does it actually, vary in color? That could be a thing which is, by the propellant, by the powder we choose, but it could also be by having an overcharge, too much unburned powder in front of your muzzle. If it's available to you, you can do measurements like speed or even pressure. In any case, have your load data with you, and yeah, we talked about that. Label your rounds, and have make notes about what you experience, because in the course of action, sometimes things are very obvious and you think through them, but later on when you try to review that, you might forget what actually happened with what type of load. So having a good documentation is always good. So after each firing, we inspect our cases and we look for pressure signs or for signs of overpressure. That is actually what it means. Now, for reference, in this picture, there are 2 cases which look pretty normal. This is like what a fired primer should look like. Although this primer, this firing pin dent doesn't seem to be in the middle, but that's not, worse. That's like fired primers look like. Now, if you experience something like this, then you found something which we call a squared primer or a flattened primer. Now, the pressure inside the case was so high, it's actually pushing out the primer cup to the breech face of your bolt, and it does it with such a tremendous force that this rim, which should be actually in its original state, gets smaller. It gets smaller until you can't recognize it anymore. And don't get confused by some of these primers are silver, others are gold. That's pretty much only the preference of the manufacturer of that primer. So here we see some heavy forging going on. We should not continue to shoot this ammunition. This is not the ammunition you want to shoot regularly from your gun, unless you want to ruin life of the gun and put yours on danger. There's some squaring here, but it's mild. Still, that's not, a propellant mass or a powder mass, which I would use for everyday shooting. So that these are the first signs which actually tell you that the current mass you just fired is too high. And of course, if you experience that, you don't want to continue firing all the other, probably even, hotter loads which you already produced. Another sign of overpressure is forging. And that is when, the engravings on your case bottom fades away. If that gets, hammered flat to that extent that these contours are diminishing, that is a sign of overpressure. In this picture, I'm not sure if that is a focus problem of the camera who took the case bottom picture, because the primer actually looks pretty cool. It has some flattening, but it's not too bad. It could be also that this case has experienced overpressure from previous loads. Now, when that happens, there's something more serious going on, and also here, that is not, the correct powder mass for your rifle for everyday firing. So another sign of overpressure is actually if we see forge marks from things which are contoured into your bolt's breech face. Now, if the cartridge you just fired has overpressure, actually the bottom of the case will be forged against the breech face of the bolt. What we see here, I believe, is the marking of the ejector. The ejector is a piece of metal which obviously helps you to eject your spent round case after it's fired. And because it's spring-loaded, it actually got pushed back by the brass, and this brass area here then is not forged, so it protrudes in relation to that area here. If you see this happening, be aware that this is not the load you want to shoot every day. Stop shooting these rounds and don't go for hotter loaded rounds in your load development ladder. Okay, ejector marks here once more. Might look different. There might be also other contours from the bolt engraved into the bottom of your case. That's a pretty good sign that, overpressure was there. If you experience a blown primer, that, the primer cup is completely missing, of course you have to find that primer cup. It probably went into your system and fell in the bottom of your magazine if you have one. But that's a sign that, something went wrong. It's either overpressure, which can then be determined by these additional markings in this case, but also that, primer pocket doesn't look round. I would discard that round, and of course stop shooting. Don't go for any hotter loads after that. Somebody sent me this picture, and I think it just looks amazing. It looks like somebody, carved out parts of that case bottom. I don't know what happened here. I cannot imagine what, type of bolt contour would actually produce that, but that would be something like, can it get worse? Obviously, it can go worse. Just look at this. The force or the pressure inside that round was so high that the indented primer cup actually was pushed out so forcefully that it entered, or it seemed to enter, the firing pin hole, producing that little donut type shape here. That's something which really is dangerous. Okay, that's it for the first video. Thank you for watching. I hope you like it, and I'm going to continue this series of videos for reloading beginners. Stay safe.